Hi everyone. This is another algebraic method for solving a system of equations. We're going to use the elimination, or sometimes it's called the addition method. And so we'll do a few examples of these. So here is the elimination method. What we're going to do is we are going to add the two equations together. But we might have to manipulate them just a little bit, because the goal of this is when you add them together, one of the variables is subtracted off, and so you're just left with one variable. So if we look at this first example right here, we could see that immediately, if we added these two together, combining like terms, 2x minus 2x is 0x. So the x's go away. And I'm left with 13y equals 13, and y is equal to 1. So we can see that this is an independent system where the y coordinate is equal to 1. All right, so then what we'll do is we can pick one of the equations, and it doesn't matter which, because they're going to intersect at this point, so it'll be the same point in both lines. So 2x plus 5 times 1 equals 9. So 2x is equal to 4, and x is equal to 2. So this system of equations is consistent and independent and intersects at the point 2, 1. Okay? Now, in the previous example, we looked at coefficients that had, the coefficients were 1, and then we could use the substitution method. And you certainly could use that method here. But we're practicing elimination, so let's use it instead. All right, we look here that if I add it, just like I have it, I would have 2x plus 3y equals 16. Well, I still have both variables, so that isn't going to work. So what if I change, or I multiply the same number towards both sides of the equation on one of these, so that when I do add them together, one of the variables goes away. All right, so you could do either variable. It doesn't matter which one. So let me show you. If I take this bottom one here and I multiply through by -1, I'll have negative x minus y equals negative 6. It's the same equation. I've just multiplied through by -1. So now if I add, I'm going to just draw a quick line through there. If I add these two together, right, I have 0x, y equals 4. And so nicely, one of the variables went away. I was able to get the y coordinate. And then I'll just plug it back in. So I've got x, and then 2 times 4 equals 10. So I have x plus 8 equals 10, and x is equal to 2. So that is my point. Okay. Now, another thing I could have done here, instead of multiplying this one by -1, is that I could actually... And man, I'm just erasing this whole thing. This is kind of fun. Instead of multiplying the bottom one by -1, I could have multiplied the bottom by -2. And this would have given me, let me just rewrite the first one, right? This would have been -2x minus 2y equals -12, right? So then the y's would cancel, and I would have negative x is equal to -2, x equals 2. Didn't I get the same thing? So there's multiple ways that you can solve these, and you have to be a little bit clever sometimes, but bottom line, you're trying to get one of the variables to subtract out. Let me do one more example here. This one over here, you're going to do in your composition notebook. I'll look at this one. All right, so we have a couple of options here, and so honestly, if I were doing this in class, I would say, which one do you want to eliminate? Because either one will work, and we might say, well, let's eliminate x. All right, so if we eliminate x, I need this to be, this first number needs to be a 6, -6, right? So when it adds together, so I would multiply all the way through by 2, and I would have -6x minus plus 10y equals 24. Let me double check that I did that right. Looks right. All right, so when I add this, this is 0x plus 0, wait, 0 equals 3? What? Well, is that ever true? Does 0 equal 3? No. So these are parallel lines. And the reason I know that is because these are different. Okay? So parallel line means it's a inconsistent system because there is no solution. So you would say there is no solution to this particular problem. And yeah, I'm having a hard time finding the eraser, and now it will erase. But this is basically no solution, right? It's an inconsistent system. Okay, so now when you're looking at one like this, notice that the top one is in order, right? X plus y equals a number. This one is not. So you're going to put it in order first. Now, and then work it. So I still want you to work it in your calculator. Work it on your paper. Use the elimination method. All right, so here, if I get something that's obviously false, right, this is no solution. But what if I get something that's true, like that? 0 equals 0 or 3 equals 3, right? Well, that means that you have the same line. It's the same line, right? So if it's true, it's the same line, and if it's false, it's no solution. And then if you get two different this, right, if you get an actual coordinate, then it has one solution, an independent system. Okay, be sure and do the system of equations example in your notebook. Try it, see what you get, see if you can interpret the results that you get. And then I want to talk a little bit about a summary of all the methods that we've learned so far on the next screen. So here's a summary of all the methods that we have used to solve a system of equations in basically two variables. Okay, we used a table. Tables are used to estimate a solution, right? It might not be exact. Graphing, if you do by hand, might also not be exact. If you do it in the calculator, you can get very exact. Substitution method works every time. Sometimes it's a little tricky if you have a lot of fractions. Elimination using addition, which means that you can just add them up. Usually it's a very simple set of equations, but you could use that. Using subtraction. Subtraction, of course, is just adding a negative. And then elimination using multiplication, which means you had to multiply times the top equation, the bottom equation, or both. So be sure you have this written down in your composition notebook, and I will see you in class.